I think it's 11, so we can get started. Good morning, everyone, for this distinguished webinar series in AI and cybersecurity, hosted by UND Center for Cybersecurity and Research. Today's speaker is Dr. Dipankar Dasgupta, William Hill Professor of Computer Science and IEEE Distinguished Lecturer from University of Memphis. Dr. Dipankar Dasgupta is a professor of computer science at the University of Memphis since January 1997. He's a leading figure in the application of bio-inspired and machine learning approaches to cyber defense. His groundbreaking works, including digital immunity, negative authentication, cloud insurance model, and authentication spectrum, have earned recognitions in Computer World magazine and other media outlets. With over 300 publications and 20,000 plus citation and an H index of 64, Dr. Dasgupta's multidisciplinary research is highly acclaimed. He has received numerous awards, including the 2012 Willard R. Eminent Faculty Award and the 2014 ACM SIGEVO Impact Award. As a founding director of the Center for Information Assurance at the University of Memphis, he has played a key role in education, training, and outreach activities on cybersecurity and information assurance since 2004. Dr. Dasgupta is a Fellow of IEEE since 2015. Dr. Dasgupta, it's an extreme honor and privilege to have you at UND's campus for this virtual webinar. Now, the time is yours to take this webinar. You should be able to see the screen, share the screen.
Yes, thank you for this nice introduction. And I think good morning in some places, good afternoon in other places. And I have given this talk in many places, so and every time I update. So there will be some slides that I already talked about, but with the different light, because this is one of the very highly important topic. And as we are moving more towards the cyber world, this kind of approach appears to be very essential. With that, this is me. And before I go on the topic, I like to give some background, who I am and what I do. So, I am one of those who had, very early 90s started working on different AI models. So from my observation, the AI is not magic, it is computational logic. And there are more than 30 plus algorithms and heuristic that constitutes the AI/ML techniques. And some are data-driven, some are model-based. So the reason I'm putting those things, that there are a lot of components that require information and knowledge of the applicator. It should not be used as a black box, and the reason is that the consequences may be significant. So many times you will see gimmicks. Oh, it can do this. Yes, it can do certain repetitive things, certain language translation and all kinds of good stuff. But it also have a dark side also. So you can see some are semi-supervised. Now you may ask why I am talking all this, because my work is based on these concepts. So all models require parameter tuning for efficiently used as a decision support to perform detection, recognition, and all kinds of things. So in the right-hand side, you can see all different other methods. They are more or less equally powerful as There is no single medicine which can solve all the diseases. There is no single algorithm which can solve all the problems. I think the industry is moving in a one-eyed way to, have everything neural network. And I think that will have a longer consequence. Again, those who are new to the field, AI is not equal ML. All are algorithms, and under that AI, under that ML, we used to call it symbolic AI, non-symbolic AI, and many others. Then there are many branches. Of course, I have not run the artificial neural network, deep neural network, CNN, and a recurrent neural network, all kinds of things. There are some application which is narrow AI, but the push towards the general AI is underway. So the two opposing factors work very strongly on the performance. It varies with the training and focus on generalization and specialization. If you make it too generalized, then it can solve only narrow problems. If you make it too special, too general, the training is poor, it can give false result, which in industry term, hallucination. So generative AI also can ensemble, create, map objects existing, and we'll talk about that. Nowadays, this is a big thing. It can do many gimmicks, but there are also limitations. This is my background. I have more than 30 years of research experience in a wide variety of AI applications. And you can see cybersecurity, from 1995 to 2015, I was focusing on application of AI in cybersecurity. Since then, I'm also focusing on security of AI. So many of my patents and publications focusing on the security of AI. And other applications you can see, and I have more than 300 plus publications. This is extracted yesterday. You can see about my profile. And I also have a number of publications. You can see 1997, evolutionary algorithm is one of the generative AI technique for engineering applications. Then another field of AI is called artificial immune system. Then the immunological computation, all the underfall that, and then advances in user authentication. Half of this book is our own research and shows how different AI ML techniques can be used in user authentication. And this talk also have a chapter in there, and there are a number of patents you can see on various applications of AI in wide variety of cybersecurity problems. I'm also running conferences and many other things. This one is computational intelligence in cybersecurity since 2007, and this year it will be in Orlando, December 58, 2024. So you are welcome to submit your research paper and participate. So with that, I'll move on to the, why authentication access control is important, because there is a legal liability. We need to make sure the access is not, illegal access. And there are many other issues you can see on the legal side. There is a reputation exposure, business consequences, and I'll show you some recent incidents of, how the access has been compromised and caused damage to many company resources. So authentication against illegal access, that's a fundamental. And then access with identity, the challenges that is how do you understand that the things are applicable in operational setting? That I'll go in little more details. What do I mean by that? So need strong authentication, and we already talked about some of the consequences, but the cost associated with the loss of unauthorized data, because authentication is kind of key to the kingdom. If someone access to the someone account or resources, then they can do lateral movement and many other damages. Liable to the loss of money and confidence, authentication tool should be capable of evolving technologies. Now, there are many ways nowadays authentications are done, and biometric is one of the major player in doing this authentication. There are different kinds of biometrics, fingerprint, thumbprint, retinal, this is thumbprint, face recognition, keystroke, voice recognition. All these are different biometrics. So important thing about this is the uniqueness. Authentication through human characteristic, who you are, that's the physical self. That's a physical biometric. And how do you collect that information to characterize a human being? That should be measurable and collectible, and which may or may not change over time. Some every 3-4 years, some maybe every year, those biometrics changes. Universality is the ability to use biometric system in real time at different operating environment. And many of those biometrics have some limitations. So we call most of this called physical biometric. Now, behavioral biometric is another area that is getting a lot of attention in many domains, and we'll talk as we move along. So any biometrics, the performance of the biometric is very important. We call it false acceptance rate, right? False rejection rate. False acceptance rate is the percentage of identification instances in which unauthorized persons are incorrectly accepted. That is, illegal people are accepted. Here, legal people are rejected, and we are looking for, there is no perfect solution. This is the point, that equal error that people look for all biometric authentication. So important issues, not very scalable with uniqueness. This is high, depending on the situation and environmental condition. We are looking for techniques which are less intrusive, less expensive, and less destructive. That is also very important. And all these biometrics nowadays can be spoofed or generated synthetically. So totally rely on the biometrics, particularly the physical biometric, is now becoming a challenge. So you can see face recognition. Face recognition, you can have a mask which movie industry created look like a human, and that can also be used. Even some bank robberies, they use the mask which the face recognition system failed to recognize. That is, and again, image morphing, you can do all kinds of face changes with the image morphing, which are equally important for face recognition. There are other ways you can see that you can add some noise. This is a whole area of adversarial machine learning. You can add little noise to the original message, and then the face may look change, but the system may detect that this is the actual face. So there are so many ways, and also the face recognition. These faces are AI-generated faces. People with these faces does not exist, but they look like a real people. So, and this article is from February 2022, New Scientist. You can see. So, point here is that biometric, though we have in every stage in security guard and where the biometrics are being used, but others should be emphasized also, and we'll get to that. So there are plethora of objects we have, we call it authentication factors, that can be used to identify who the access is or whom the access is given. So they can be classified, those who have taken the course on user authentication, you know what the user knows, that is the knowledge, that password, PIN, passphrase, what the user has, that is smart card, digital certificate, driver's license. Where the user is, these are old days it was GPS, now IP address, device ID. A lot of other things are now can be used along with the who the user is. That's the physical biometrics that we already covered about. But now we are moving to the world of devices where human may not be directly involved. So IoT sensor features and characteristics are also now part of this authentication mechanism where this are being played an important role to give access to, for example, the blood sugar monitoring system wants to communicate with the server, with the patient information. They have to be mutually authenticated that I'm sending the information to the right device, and the right device also getting the information from the right patient. So there need to be a mutual authentication, and different authentication factors plays a major role. Now we know that password, login and password though still exist, does not provide enough security from the authentication perspective. So people move to the multi-factor authentication. 2 or more modalities are used for identity verification. So password, then you go to the other factors, then get the authentication. There are a number of companies. I don't know whether you can see top of my screen. I don't see my screen top, but there are different products out there on multi-factor authentication. Cisco Duo, you can find the evaluation guide for different multi-factor authentications. And these are the list companies. Now, as you know, things are continuously updating and cloud under. So I'll show only Microsoft one, but there are others are also, some use 2 factors, some use multiple factors. So this is what Microsoft Azure looks like. You register with your login password, then as the time you can add other authentication the way you want to be authenticated. OTP is one of the standard one, and when you use it, it will take from the cloud and get that concept of multi-factor authentication. So here, the thing is, you as a user decided that I'll be first checked with the password, then it will be OTP, then the third thing. So it is mostly user driven and predetermined. So the concern with that, the benefit is, you can see it provides choice to the user during the authentication to verify their identity using different factors, right? But those are predetermined. So how to choose a better set of authentication factors out of all possible choices in a given environment, that multi-factor authentication do not provide that answer. So then it moved to the, so how about we can make it, and that's why the adaptive things are coming. I'll show you that multi-factor authentication, though better than single factor, but you can see there are a lot of attacks recently. The Uber hacking opened this, all these are affected. A multi-factor bypass attack means the worldwide security industries heavily relies on MFA. So that was September 2022, and Okta is a well-known company on a multi-factor authentication like Duo and others, but they are also got hacked. You can see MFA bypass attack in Okta detected in January. So this is the situation. We have many factors, but the pattern is fixed. So we call it a static multi-factor authentication. You do this, do that, and any hacker who actually in a hacking business, they can capture the static pattern and can even the OTP from the phone or SMS. If you look at last week's thing, eSIM swap, you can do little trick to get the eSIM swap and get the takeover of the phone numbers and get the OTP to their system. So that's the issue. But in a dynamic that, which will be chosen dynamically at different triggering time, that's our focus. But there can be two types of dynamic. One is a random. You randomly choose out of your all possible authentication mechanism. But the challenge with that, sometimes it may select which is not available under the current environment. So adaptive can take care of all this, limitations and expand the horizon based on many other things. And I'll give a simple illustration, but in a current state, it can be in many ways. So we use the term adaptive multi-factor authentication in 2016, and we have a patent on that. But since then, if you Google it, there are many companies are claiming, many publications are used adaptive multi-factor authentication, but in many cases they do not refer to our work. But those historical perspective, we are the first who used this idea and conveyed that message to the world how this can be done. But at the same time, the industry, those who use the term adaptive, they are not really adaptive. And I'll get to that. So you can have the user experience, what devices you are using or IoTs, and you considering different factors, including the behavioral, it will select what will be the best authentication modality to be used based on the communication or connected media, how the person is connected, in what applications they are running, and the surrounding environment. So considering all this, and it can be added other operational situations also. This is not limited to. The concept is you take into consideration all possible situations under which the access is allowed, and then decide from your basket of things, maybe hundreds, maybe thousands, what is the best. And that selection is where the artificial intelligence technique take into place. And I'm going to get it there. Here is an illustration. So there are, in this illustration, there are face recognition, thumbprint, voice recognition, passphrase, and SMS. So this is the time, and we tested in a online course environment. I'll talk about that. So now it is a noisy environment, so voice recognition will not be selected. It is a low light environment, so face recognition may not be appropriate. But also, if both are down by hackers, do it low light and voice, then other passive things will be selected. So, so initial idea was that you have a number of authentication factors. These are, keystroke dynamics, voice, fingerprint, all these are, and this is your working environment, classroom, online courses, we tested with this. And then you have device through which you are connected and the media through which the connections happened, and the operating environment, where is it a Starbucks, is it a train, or is it an airport? Considering that, the selection algorithm will find the best authentication factor for which the person, in this case, can be authenticated. So this illustration showed that face recognition and fingerprint. So it is a multi-factor, but adaptively selected by considering all these things. Adaptively selected from where? From the list of authentic factors are there. And actual algorithm is stored in a virtual machines, maybe in a same device or in multiple devices spread across. So which one will be activated depend on this selection and displays, and then that factor will be used. And this can be kept in a highly secured environment. Only certain tokens can get into it, and with mutual authentication. So this is the overall diagram and objectives. You have a pairwise preference, and then so we considered it as a multi-model, multi-objective optimization problem, and then we ran some algorithms. So this is the basic foundations, and there is no room for going in much details, but I'll show you how things are done. Here is the factors are collected, that is how someone will be authenticated, and there may be n number of factors of different types. So the types, factors, modalities and different factor types are then integrated and combined, and then making it as a multi-objective optimization problem to solve it. So it may be thousands of them, it may be few of them. So how many are there? That's a application dependent. So how we do that optimization? This is the field called generative AI, a frontier of AI. So generative AI techniques has evolved over the years and has rich historical background. It became increasingly popular, right? And there are many applications, as we see in everyday news, everyday applications are coming up, but mostly these are using generic large language model. I divide them into two categories in my talk last year, and now I'm seeing there are some products coming out from Microsoft and others. They're also now labeling as small language models. So this is mostly neural network based with back-end and front-end natural language processing. There is a knowledge graph which stored the information that has been trained, but most of them are pre-trained, and I'll show you this is how most of this today's large language model work. You have a pre-trained, so you put structured, unstructured data, voice to text conversion. These are already existing, then forming it into tokenization, and then use these learning models, which are in many cases they are recurrent neural network or transformers of different types with encoder and decoder. Then it can do different types of question answering, natural language interface, and all this. But after the training, it's stored in a knowledge graph or knowledge base from which the information is extracted for different purpose. So nothing comes from the sky. If you see a text message creating an image, that image component should be there in this knowledge graph in some form, whether it's a vector or so this combines to produce the aesthetic design of what the user looking for. And in case of text generation, the association of words based from the historical data is very important in this case. So pre-trained generative models are the current situation, and it seems it revolutionized the way people do work. So in my mind, again, that's my interpretation, generic LLMs, you have a lot of them now, Falcon, Gemini, and all others are coming. So you have the whole 100 times bigger Wikipedia is there, and then people are using plugins for doing different things. So these generalized large language models are very expensive to train, right? And there are a lot of handcrafting, which is behind the scene, corrections and all this human labor, and then it suffers from inaccuracy, bias, factual errors, hallucination, and all kinds of things, because it has been created as an universal, not for specific applications, and these plugins or add-ons using this large language model for different purposes and cannot be efficient. Why you need the whole thing when you are solving a small problem? You can train the small language model for that purpose only. So because people don't know, and the wrapping of the language translation, they're taking benefit of this. But it's a wastage of resources, and global data collection and removal of metadata references may violate privacy, copyrights, having legal, ethical, and regulatory consequences. That's are coming, and you'll see European Union, issued some fines to companies and others, the copyright violation and all other patent violation, all these things are coming. So parameterized small models seems to be the future, and it can be curated data and trained with all these legal ways. You can have a first in online way for specific things using natural language interface. So and this one shows how parameterized small models in the past, you can see it was 1997, created different kinds of images using genetic algorithm. I'm going to show you. And those are very powerful. The music composition, everything could be done. But what's the difference now? Now we have the thousands and thousands times of computational power, thousands and thousands storage capacity, and that making things as if even though algorithms are expensive, that does not affect, and things are happening. So you can see in 1997, this kind of pictures were created using a different kinds of algorithm, and I'm going to talk about what is that algorithm. It's called genetic algorithm. People sometimes call it evolutionary algorithm, and you start with a population of points, so you need to have the knowledge of the algorithm, and you parameterize them and make a population. Then evaluate how good that each of those in a current environment using some fitness measure. And then you modify this based on these operators. There are many other operators. It's a simple example. Based on these operators, you perturb, you change, and see how good they are. So that process, same as the neural network training, you tune the weight vectors slowly so that it can learn. That same process, you will do that, and you come up with, in our case, it was a multi-objective optimization. We came up with a solution that is, we call it Pareto optimal, which is satisfied, as I showed, in 4 different objectives. So, and these are the good solution which satisfy all the objectives. Then we can take 1 or 2 of these solutions and use it for authentication. What this solution is, assume this one saying use GPS location and face recognition. Others may say, considering all this environmental factor, use 2 other things. So then we have a variability. Sometimes I can choose this one, sometimes I can choose that one. So it will be hacker-proof as much as possible. You have many options. Among that, you are taking a small subset, and that subset will be used at that point. So it is illustrated here in this. So at this time, so you as an user, it's a part of continuous authentication. And say every 2 hours I should be checked. So password and CAPTCHA is used for checking. Another face recognition PWD and password. So when we developed the concept in 2015, we had started with 6 to 10 different modalities and with different factors. In face recognition, we never use the entire face for recognition, only the eye portion, only the lips portion, because to make it more real time. So you can see 3 different situations, time elapsed. Someone is logged into his bank account for a long time, so they have to be authenticated. The device seamlessly using wireless, and the media changed from Wi-Fi to wireless to cellular. So this is the illustration, different things. And so here, there is no pattern that can be captured if you have a large number of them. So we have a video, it is in YouTube. I'm not going to show it because of you can go to the YouTube and find it. This is the patent that we have. What is the advantage here? It can does the continuous identity protection, right? And because it allows different kinds of authentication factors, what you have right now, or you can also, for future, you can add more as it available. It's a cloud identity management, provides a cloud-based solution to administer your existing service, right? But the power isn't just in decision. There is nothing that the hacker can exploit is stored there. When the triggering will happen, now the user will need to be authenticated, then only it will run that algorithm in background and give the solution. They use this too for verifying the user. Again, it will require deeper knowledge of the algorithm. It cannot be plug and play. So, and that's why the machine learning behavioral approaches are being used. It has been built for adding future thing in mind. Wide variety of applications I'm going to show. And I also showed that, seen that NIH is using it for various purposes, though the people who have reported it had very limited knowledge on the adaptive multi-factor authentication. So applicable to risk-based, role-based, context-based, sensitivity-based, continuous high-confidence identity authentication for banking, including online fund transfer. If it is cross-border transfer, then there'll be more number of authentication factors should be verified. If it is within same account, maybe one authentication factor will be tested. So you can have wide variety now online training, and COVID give us a situation that every student now prefer to work from home, study from home. But that administering the exams and assignments is very critical, and so it can serve as that. And there are many other applications you can see. It can also apply at a different level. Application level in financial application, email. If you are a regular user, maybe one type of authentication may be used. If you're an administrator or super user, then more rigorous authentication, including active and passive, can be used. Even, PDF, we get the payment bills through PDF. And what did they ask? Your last name and last four digits of your social security number. Many cases, these are universally known. So there is no security there. So things of that nature, that it can be changed dynamically based on how and where the user accessing it. The model has three modes. Normal mode that trigger authentication factor at specified events, wireless media change time threshold, that illustration. But if it goes to the vigilant mode, when the operating environment suggests not to select some active modalities. That means I have shown in my illustration the voice recognition and or noisy environment and low light. So that will go in a vigilant mode, that more frequently the user have to be authenticated. More passive and standby authentication factors need to be considered. But it will go to the surveillance mode. That is, still the user is allowed to continue working, but now more rigorous authentication, back-end authentication, then also intrusion detection systems and others will be activated to check the user behavior. So in our second phase, we added more devices. I think I'm almost running out of time. Give me 2 more minutes, the future direction, then I'll leave. So more things are in version 2. Now there are a wide variety of applications, not only us, many people are doing it in a mobile device, geolocation, altitude, and considering all these things, that the adaptive concept is being adapted. You can see these are information collected from mobile devices to consider how the user need to be authenticated, not only by active, but also passive way. I like this paper which came out in 2018, and they took our concept and said that adaptation can also be added in many different levels, like change of context. We showed some of the context, time of the authentication. If it is in the midnight, we have to consider different types of authentication factors and parameter structure, user behavior. So at different level, the different kinds of authentication factors can be selected, which are context dependent, risk considered, and which is appropriate in that environment. So the whole area of identity science has emerged, and many of you know, it is not only who you are, that's the physical, but environment is also taking major role. The environment, that username, where I say live, my connections. So the cyber presence is also considered as identity factor of an user. That field is emerging, and you can see many applications of that. And adaptive multi-factor can take advantage of this in a big way. So instead of making it static, it can make it adaptive. And also, when we are on a computer or any computing device, there are a lot of trails of information that we leave behind the way we type, the type of word frequently used. So those are the context aspects can be used also as a weak authentication factor along with others. So these are passive, but it can give some level of assurance that is important. And with that, I will finish with one new area that is emerging called zero trust. Zero trust, and I was last year in DoD meetings where it shows that this kind of concept is use of adaptive multi-factor authentication for user device and processes. AMFA can be used for IoT for continuous validation, authentication and authorization, establishing mutual authentication for every privilege access. And that's the concept of zero trust is never trust, always verify, can satisfy using this method. But again, the real caveat is just using adaptive may not be adaptive. It have to have that power of AI machine learning that make it more robust. With that, I like to stop and looking for some questions.
Thank you very much, Dr. Dasgupta, for a very fantastic presentation. Thank you so much for giving a very nice summary of what's going on in state of the art and also your work. We have time for questions, so folks can put their questions online so I can able to coordinate. And I think we have a lot of questions coming in. So the first question is, what are the privacy-related implications of AI surveillance of a user?
That's a very good question. You know, we are always been in surveillance. If someone thinks that I'm not being watched, whether that being used or not, that's we have the Einstein program. Einstein 3 is running on. Every state has this Einstein program is going on. All electronic communications are being stored and processed and analyzed. How much that been used, time will tell, and I don't know. So yes, privacy is important, and many factors that considered who you are is also important for authentication. Otherwise, this fake news, fake messages which AI generated or human generated will consume our society. So identity science is one of the important things that will validate the person who is claiming this is verifying it. There are other areas, anonymity is important, like voting, evaluating, but you cannot make everything for everything. So where I'm doing the bank transactions, where I'm doing the critical communication, why anonymity is needed? I need to be strongly authenticated, and my identity should be 100% verified. So privacy, in some cases, when my interest is involved, company interest is involved, and we are mutually agreed that you can verify me if certain situation arise, then privacy issues is resolved. Next question was how to make boundaries between normal and other mode. That's a technical question. There is no precise solution. If you look at the firewall rules, if we look at intrusion detection rules, if we look at spam ham rules, there is a fuzzy area. So having continuously authenticated in a discrete continuous authentication, you may miss one time having normal or abnormal, but second time you may not miss. So we are in a dynamic environment where it is a it is a two-player or multiplayer game, users and the others who wants to cause harm, the hackers, nation state funded criminals, and all other who are making money for different by ransomware or any other ways. So so I don't expect that any easy solution or one fit all will work here. So what is needed is a deeper knowledge. If I'm applying this to banks, I have to make sure what bank transaction or financial institute transactions involved. I cannot use the same thing in the same way in a social media access. That's where I think the industry is making mistake. See, I'm switching a little bit in single sign-on concept was developed in early 80s for an enterprise, for an organization to seamlessly connect to different resources, different servers within the organization. Now, if you use that model across industry, some are free, some are paid. I'm giving an example. In 2018, Netflix had to switch off. Is it Netflix or they had to? I forgot. So shut down all their users because their token. It was not last Facebook. Because the token, because behind the Facebook there are 25 to 50 companies who are paid, like Netflix and others. So you can connect to the Facebook and you can seamlessly use Netflix, which is a paid, and many other things, and it is authenticated through the Facebook. Facebook is a free and open, and others are paid. That's where the conflict comes. Single sign-on may not work there.
Thank you. Thank you for those detailed things. I think we have follow-up questions. What do you think about potential of AI to act like a human or hack the data to pass MFA? Would let you answer that question first. What do you think about potential of AI to act like a human or hack the data?
I personally who devoted 30 plus years in different AI techniques. Yes, AI is a double-edged sword. You can do good thing, you can do bad thing. Now, that's why I strongly feel regulations be needed. We should not let it go like social media. So if the social media was regulated in a way that propaganda, misinformation, and all other hate can be stopped, and the companies will be liable for posting that, then we would have in a better situation. But with AI, less number of people know how the AI works, though everybody claims that they are the AI experts. It has significant, as I said, it has a double-edged sword. You can do good thing, you can do bad thing. So my talk, I'm an IEEE distinguished speaker. One of the talk I gave and many times is AI versus AI. You can build an AI to do certain things for defense. I can build another AI to break it. Now, we have not reached to the point, but time is coming that AI will fight with AI, and who will win will depend on who has more flexibility in their AI algorithm. So
Right.
generic models are not going to work. So, and that is true for MFA also. I hope I was able to answer that.
Thank you. One other thing, I do work a lot on electric grid thing. I keep on hearing. I specifically want to ask your perspective on OT environments, whether you're looking at utilities environment. A lot of significant attacks have been happening, and people wanting to use cloud, and some companies don't want to use cloud. They want a dedicated server, and yet they want that edge intelligence. How do you see we go forward in an OT environment? Yes, we need some aspects of AI. But what is your perspective for folks who are listening from power companies, or utilities to see, how do we, there is I'm looking from an academics point of view, how we should work on in future technologies, envisioning, a way of hybrid, or, I don't know. That's another thing that I'm really
So,
to.
there is a cost benefit analysis that every industry is doing. Moving to AI, the argument is, and if you look at my publications in 2013, I gave a number of talks at MIT. They're applied. So the computational cost, keeping the skilled workers in an organization becoming more expensive. It is not the hardware, it is the software licenses are more expensive. So every company, even the universities, are moving to cloud. So my paper and my talks are who is responsible in cloud? Because cloud environment has three players. One is the cloud software, hardware, with a platform as a service, or infrastructure as a service, or software as a service. And where they are located, that's not important. And in true cloud environment is the concept of multi-tenant. So there will be many tenants. So now, as I said, there are three-player cloud provider, then the communication, the telecom companies, the ISPs, it goes through a number of them, and then the client side, the organization. So any place there can be security breaches. The normal firewall, where there's a perimeter defined, is getting blurry. So in terms of, again, my undergraduate is in electrical. I worked in power plant, Westinghouse power, gas turbines. So we also have a number of projects on smart grid, DAR, and other things. So there are two things. AI will be coming in every aspect. So you cannot stop that. You can also need the cloud, but the way cloud is now transferring, it is moving to the edge cloud. So you may not have to, and that is more and more happening because of the regulation, GDPR-like of regulation. You cannot take European data to other continent. You cannot do certain things. So the edge cloud will be, there will be a smaller storage processing units that will be locally settled, and you can operate through, but that will be a hierarchy. Then certain things will be going to the big cloud environment, and you will see the federated learning. Again, I'm moving to another topic, is going to give a big role in that kind of privacy enhanced machine learning technique, where you can do things locally within your premise or within your organization. Only certain aspects, parameters will go to the upstream cloud.
Great. In the interest of time, I think let's have one more question. I think, are there metrics to quantify the generalization and specification of the models? If so, what are your perspectives on a couple of metrics on those two?
So I just, in my survey, the Duo Cisco have a guidelines for evaluation. You can look into that. It was released, I think, 2023, 24. NIST provided multi-factor authentication evaluation guideline. And we are a researcher at the university. We have very limited resources, not only in terms of buying equipments. Nowadays, I think every university, other than the top ones, the highly interested student, because everybody wants a shortcut to get to the job, and job market is good. Knowledge gathering is now becoming secondary. So I would say that that given the opportunity, students should be given enough time and resources to understand at the deeper level of as we are going to more and more sophisticated systems, the number of people who knows in details from top to bottom are very few. So we have to create an environment, a large number of professionals know many aspects. I'm not saying every aspect, many aspects, how it works, giving the explainability, then interpretability. Those are the areas should be more focused in my mind.
Thank you so much for your time today. I think well, it's already noon here, but I think with this, we will conclude the webinar. And as part of a token of appreciation, UND will send you a nice plaque and a certificate of appreciation from our dean. And thank you, Dr. Dasgupta. I think I look forward to work with you and collaborate with you, and as we move forward. And maybe in closing thoughts, maybe I'll say one few 30 seconds. What still inspires you to continue in this step in the AI, in what motivates you to continue because we live in an era that there are new technologies are there. Can you conclude just a few seconds?
Yes, I'll conclude in 1 to 2 sentences. It motivates me. I see that the struggle we had with AI implementation because of the computational power, because of the storage. Now that barrier has broken. Now nobody talks about, Moore's law. Nobody talks about, oh, we have limited. It seems the unlimited space, unlimited computational power, particularly from the cloud provider's point of view. And this AI ML techniques, if they are correctly used, it can change the society. When I'm saying correctly use it in a medical field where desperately needed, and with proof, with more rigorous experimentation. One complaint on most of the AI is it gives a probabilistic result, which is true, but then it translating to the deterministic can be done, and that can give that interpretability.
Great. Thank you, Dr. Dasgupta, and you have a nice day. Thank you so much. This webinar will be made available on YouTube. We'll send you the link, and we'll be in touch with you via email and phone. Thank you so much.
Thank you.